going to continue working with dividing polynomials, but this technique will be synthetic division. So our objective is to be able to divide polynomials using synthetic division. But let's first review over using just polynomial long division. So if we take x plus 2 and we divide it into x squared minus 6x minus 25, the first step is to say x times what gives you the x squared, and you multiply that by x, so x times x is x squared, x times 2 is 2x. We want to subtract when we do this, so x squared minus x squared is 0. Negative 6x minus 2x is going to be negative 8x. Be careful with your subtraction. And then bring down the negative 25. X times negative 8 is equal to the negative 8x. So negative 8 times that is negative 8x. Negative 8 times positive 2 is negative 16. We're going to subtract. Negative 8x minus a negative is plus 8x. That's gone. So 0x is negative 25 plus 16 because minus a negative. And so we get that, we get a negative 9 when we subtract those. So we get for an answer the x minus 8 plus negative 9 over the divisor x plus 2. Now when we're doing synthetic division, we're going to try to simplify the actual mathematics of it, but you have to remember the technique, because what it does is it strips away the variables, because the variables change. X squared and x, well, I mean, we have the same variable, but the exponents change. We strip those away and try to do just the math of the that's involved of bringing one term down. So let's go ahead and talk about the setup, because the setup and procedures here are very important for this. So the first thing you do is you put the terms in order, make sure it's in standard form, and then put in 0 as a placeholder when there's missing terms. So whenever there's a missing term, put in a 0 to make sure that you've got that placeholder in place for us. Now, the next thing you do is you get rid of the variables. That's what's going to make this a very interesting technique. The variables will be gone, and list the coefficients. Okay. Next, we're going to have a box here, just a little kind of a backwards L. So I'm going to call it the box. In the box, write the opposite of the constant in the divisor. All right, now the next thing is you're going to be leaving a line space. So there's going to be a line of numbers. You'll leave a space line here and then draw a line. So I'll show you what that looks like in a couple moments. So that's how you set it up. That's to get the problem ready. Now the steps, actually, the procedure for doing this is you want to bring the first number down past the line. That's the line we just drew in the last step, past the line. This is kind of the critical step that people kind of forget to do. So I'm going to put a box around it, because this is the one that kind of leads to the most errors in this process. Next, we're going to multiply, add, and repeat. You'll see what that means as we go through the problem. And then we're going to reinsert the variables, because we took them out, remember, in that earlier step. Once we're done doing the process, we reinsert the variables, but we have to start with 1 degree less than our original problem. So starting with 1 degree less than the dividend. That's the original thing we were dividing into that we stripped the variables off of. All right, so let's see what that looks like. We're going to try this with several problems. So taking a look at this first problem here, notice that when this is division, make sure when you see a division, you know that that means the same thing as x squared minus 6x minus 25 all over x plus 2. That's another way to write it as a fraction. Or the third way we could write it is that you could have x squared minus 6x minus 25 times this x plus 2 to the negative first power. So these all mean the same thing. That's the way you'll see the problem. Remember, a negative 1 power means that it becomes a reciprocal, and that would move it to the denominator. So fractions mean division, so it's like this, and that negative exponent means you're going to do a reciprocal underneath. All right, so let's do our setup. The first thing is the dividend here is in order, so we're all set with that. Next, we're going to get rid of the variables and list the coefficients. So this is a 1, a negative 6, and a negative 25. So don't list any variables, just take the dividend and list the coefficients. Then we're going to put a little box over here, backwards L, and in that box you put the opposite of this constant that's in that binomial divisor. So when we take that, we're going to take that and make it a negative 2 instead of the positive 2. Now, next step is to skip a line and draw another line underneath it. So I've got space here because I'm going to be writing numbers. So skip a line, write a line. Okay, now the first step, this is the procedure. We're down, that's the setup. The setup's all ready for us. Now the procedure is bring that first number down underneath. Okay, that's critical because people forget that. Bring it down and now we're ready to go. What you do is you're going to take, when it says multiply, add, and repeat, I'm going to multiply these two. Now this arrow won't typically be there, but just to illustrate what we're going to do, this one gets multiplied. So negative 2 times 1 is negative 2. You write it right there underneath the next number, okay? And then you add straight down. Notice this is one of the advantages of synthetic division is in polynomial long division, we were subtracting, which leads to a lot of people making mistakes. This one we're going to add straight down and get a negative 8, and so it will avoid some of the errors that we make. Now we're going to take the thing in the box and multiply it by the thing under the line, just like we did here. So negative 2 times negative 8 is a positive 16. That's the next number you put up underneath here above the line. Now you add straight down for that, procedure. Notice we're repeating this. And so you add straight down, you get a negative 9. All right, now you might wonder, what are these numbers? These numbers are the coefficients. Notice that this problem is exactly the same as the one we did up here. Notice when we did this one up here, we got this same problem here that we did up there. Notice that that 1 is the coefficient in front of the x. The negative 8 comes next, and the remainder is negative 9. So you get the same numbers as we did with that, the same problem, but now we just have to put the variables back in. Notice that this quotient was 1 degree less than the original dividend. The dividend is an x squared. We're going to have this one be 1 degree less than it. So when you go back to putting the variables back in, reinsert the variables starting with 1 degree less than the dividend. I started with an x squared. I'm going to start this one with a 1x minus 8. So I go down in degrees here when to the next term. Plus, this is my remainder, negative 9 over my divisor, which is x plus 2. That's my final answer when I do this problem because of these coefficients. This last number, I'm going to put this out here just so you remember, that last number we ended with the remainder for it. Let's try it with this next one. Let's follow the same process. We're going to speed it up a little bit. So the first thing we're going to do is, there's no missing terms, so we don't have to fill in any zeros. So I'm going to just strip off the variables and put the coefficients. So I'm going to have a 1, a 14, and a negative 10. No more variables on that. In the little box on the side, I'm going to put the opposite of the number down here, so a positive 6. Skip a line and draw a line underneath here. The first one, remember, you bring that first number past the line. So bring that 1 down below the line. Now you multiply here. This one in the box gets multiplied by whatever's under the line and then written in the next spot. So 6 times 1 is 6. Add straight down, you get a 20. Now you do 6 times 20 is 120. Add straight down and you get 110. So those are my numbers, but I have to reinsert the variables. So I started with an x squared. This is going to start with an x to the first. So 1x to the first plus 20. So you're going down in degrees. This is my remainder. So I'm going to add 110 over the divisor x minus 6 for my final answer. Okay, now let's try another one. So we're starting to get the procedure down here. We can maybe speed the process up a little bit. Notice that there's no missing terms here as we go down in order. So I'm going to take this, I'm going to strip away the variables. I'm going to make it a 1, a negative 4, a 6, and then a negative 4. I'm going to put in the box the opposite of that number in the denominator, so a positive 2. I'm going to skip a line, draw a line, and then I bring that first number down. So nothing goes in this spot. I bring the 1 all the way down below the line that we've drawn. This gets multiplied, so 2 times 1 gives me 2 right in the next slot. Now, I multiply these to get that, but I add straight down here. Negative 4 plus 2 gives me negative 2. Multiply these two, so the number in the box gets multiplied. So 2 times negative 2 is negative 4. Add straight down, you get a 2. Multiply these two, I get a 4. Add straight down, and I get a 0. So I get a remainder of 0. Just so you know, when you get a remainder of 0, that means that this is actually a factor. So a remainder of 0 means it is a factor. We have no remainder at the end. All right, so let's go ahead and write this out. So I'm going to use these numbers as part of my final answer. These are the quotient coefficients. So I'm going to start 1 degree less than this one. So I have an x cubed here. I'm going to make it 1x squared. Next, I'm going to make it minus 2x. I go down in exponents, plus 2. And I don't have to write plus 0 over the divisor x minus 2 because I have a remainder of 0. All right, so that gives me the factorization. Let's do this last one here. Okay, so I'm going to just strip away all of my my variables, but notice I'm missing an x cubed term here. So you got to think of this as being a 0x cubed, and also I'm missing a constant out here. So I'm going to have a plus 0 at the end. So I'm mentally thinking I got to insert those 0 placeholders. So strip away everything, I get a 3, negative 5, 0 for my x cubed, negative 43, 6, and then a 0. So a lot of numbers. This would be a long polynomial division problem. It would go way down on the paper. Here it keeps it condensed, and also we still have that advantage that instead of subtracting, we're going to be adding this instead. All right, so next what I'm going to do is put in the box the opposite of this number, so a positive 3. Leave a line, draw a line, bring this number all the way under the line. This one in the box always gets multiplied by what's under the line and filled into the next slot. So 3 times 3 is 9. Add straight down, you get a positive 4. Okay, next you're going to multiply. 3 times 4 is 12. Add straight down, you get just a 12. Okay, now notice if you had missed that 0, you would have missed part of the answer part for the problem. Now I'm going to take 3 times 12 is 36. Add straight down, and you're going to get a negative 7. Next, you're going to take 3 times negative 7 is negative 21. Add straight down, 6 plus negative 21 is negative 15. Now I'm going to go ahead and take 3 times negative 15 and get negative 45. Add straight down and get negative 45. So my remainder is negative 45 at the very end. So let's fill this back in with the variables since from what we started. So I'm going to start with 3, and I'm going to have an x to the 4th, 1 degree less than my original dividend. So 3x to the 4th plus 4x to the 3rd, just going down in powers here, plus 12x squared minus 7x, then minus 15 is my constant, and then I have to go ahead and add the remainder, which is negative 45. I'm going to put it over my binomial divisor, x minus 3. So I get a really big answer here, but it comes a lot faster than using the polynomial division and the polynomial long division, and also I have the advantage of probably it being more accurate because I'm adding down as part of it. So polynomial long division is a valid way to divide polynomials, but synthetic division, by stripping away the variables and just condensing the work on it, can be a very efficient and fast way to do these polynomial division problems. You just have to remember that we have many procedures for the setup. So the more you practice the setup, the better you'll get at it and following that procedure, and then you'll get your final answer to the division problems.